Assalamu alaikum students, welcome to my YouTube channel and today we will discuss about chromatography. What is a chromatography and techniques? We started chromatography, a technique for separating the component or solute of a mixture on the basis of relatively amount of each solute distributed between a moving fluid stream called the mobile phase and continuously stationary phase. The mobile phase may be either a liquid or a gas, while the stationary phase is either a solid or a liquid. Kinetic molecular motion continuously exchange the solute molecules between the two phases. If for a particular solute the distribution favors the moving fluid, the molecule will spend most of their time migrating with the stream and will be transported away from other species whose molecules are retained longer by the stationary phase. For a given species, the ratio of the time spent in the moving and stationary radius is equal to the ratio of its concentrations in the regions known as the position coefficient. The term absorption isotherm is often used when the solid phase involved. A mixture of solute is introduced into the system is conformed region or a narrow zone, the region whereupon the different species are transported at different rates in the direction of fluid flow. The driving force for solute migration is moving fluid and the resistant force is the solute. Affinity for the stationary phase, the combination of these forces as manipulated by the analytical producers are separated. Chromatography is one of the several separation techniques defined as the differential migration from the narrow initial zone. Electrophoresis is another member of this group. In this case, the driving force is electrical field which expert different forces on solute of different ionic charge. The resistive force in viscosity of a non-flowing solvent. The combination of these forces yield ion mobilities peculiar to each solute. Chromatography has numerous applications in biological and chemical fields. It is widely used in biochemical researches for the separation and identifications of chemical compounds of a biological origin. In this petroleum industry, the technique is employed to analyze complex mixture of hydrocarbons. As a separation method, chromatography has a number of advantages over older technique, crystallization, solvent extraction, and distillations. For example, it is capable of separating all the components of multi-component chemical mixture without requiring an extensive foreknowledge of identity number. A relativity amount of the substance present, it is versatile in that it can deal with the molecular species ranging in size of the various composed of millions of atoms to the smallest of all molecule hydrogen which contain only two. Furthermore, it can be used with a large or a small amount of material. Some form of chromatography can detect substance present in an attogram, 10 to the power negative 18 gram. This making the method a superb trace analytical technique extensively used in detections of chlorinated pesticides in biological materials and environmental in forensic service and its detection of the both therapeutic and abuse drugs. Its dissolving power is unequalated among separation method. Early development, the first purely paramagnetic application of chromatography was that of the early dye chemists who tested their dye mixture by dipping sting as pieces of cloth or a filter paper into the dye vat. The dye solution migrated up to interested material by capillary actions and the component produced bands of different colors. In 19th century, several chemists, chemicals, careers, and deliberate experiment to explore the phenomenon. They observed, for example, the development of concentrating colored rings by dripping solution of inorganic compound onto the center of piece of filter paper. A treatise was published in 1861 by Friedrich Grob Lesorder describing the method and giving it the name capillary analysis. The discovery of chromatography, however, is generally attributed to the Russian botanist Mikhail S. Tusvest, also coupled Tusvest, because in 1901 they recognized the physicochemical basis of separation and applied it in a rational and organized way to the separation of plant organisms. Tesvet described a technique that is used today is essentially to seam form. He packed a vertically glass column with adsorptive materials such as the aluminium, silica, or powdered sugar, added a solution of the planet pigment to the top of common, and washed the pigment through the common with an organic solvent. The pigments separated into the series are discrete colored bands at the column divided by region entirely free of pigment. So this was our topic. Hope you understand. In the next lecture we meet. Goodbye.